Thanks, Sasha. Okay. Good evening and good afternoon to everybody who has joined the conference. First of all, I would like to welcome you to HP Data Protectors 6.0 DB2 Integration virtual class. My name is Bhargav Sangam. You could pronounce it as Bhargav, and I'll be your instructor for the next 3 hours. I have already sent you an email with a Word document and a little binary. So please read that document once we start off with the lab sessions, not now. We will hold a 1-hour theory session. You can, of course, interrupt me anytime you would like to and ask questions and get them clarified. Once we are through with the theory part, I will open the lines for a brief question and answer session wherein you could answer additional questions. So once we are through with that, we will start with the lab sessions where I will give you the credentials for systems onto which you could log on to practice your DB2 data protector integration concepts. You can test them live on a live system. And I have earmarked 2 hours for that. So the total session would be for 3 hours, 1 hour for the theory and 2 hours for the lab. Also, as I mentioned in the email that I have sent, there is a binary which you just need to double click and it will open a small GUI. The instructions on how to use that are in the supporting Word document that I've already sent in an email. So once again, my name is Bhargav, and as I see, we have 4 students. One is Mark, another one is Mark Heinrich, the third one is Ji Fang Huang from Shanghai, and also Guo also from Shanghai. So I have one Mark who is trying to connect. He's not Mark Heinrich, it's another Mark. So if you could bear with me for a couple of seconds, we could start off with the session because Mark is trying to patch in through to the voice conference section. Okay, so let us start. Once again, welcome to Data Protector 6.0 DB2 Integration class. So in the contents, we will see the overview of DB2, how it is integrated to Data Protector, that is the marriage between DB2, which is a database, and Data Protector, which is a backup application. In the next sub-module, we will be talking about backup and restore of DB2 database with Data Protector. As we go on, we will also discuss the limitations of this integration, do a little bit troubleshooting, and at the end, as I already mentioned, we'll be doing a lab. So please do not hesitate to ask any question at any time. The lines are open. You just need to say hi, and Tasha, the operator, will patch you through to me. Okay, so in the first slide, we will kick off with DB2 components. As you see here, in this slide, we have an instance, the yellow box, where you see a big yellow box, which is called an instance, which has inside a database. Now, what exactly is an instance? A database instance in DB2 terms is nothing but a code that manages data. It controls what can be done to the data and manages the system resources assigned to it. So basically, an instance is a complete environment. It contains the different database portions. As you see here, in this example, you have one database. It could also have multiple databases. For example, this could be another database. This could be another one. This could be another database. And this is this big one is actually a database blown up. Inside, as you see here, a database has different portions, that is, and different nodes. A database, in case of DB2, could be logically distributed among different servers. That means you have one instance, and an instance could be made up of different database partitions. So if the database has only one partition, then it is called single partition database. And if the database has multiple database partitions, it has different partitions of the same database instance, but spread over different physical systems. It is equivalent to having a big database distributed across different physical systems. So what is the advantage of such a thing, where you have your database completely distributed over different physical systems? Of course, in that case, you could set up an extremely huge database and leverage the good hardware on different systems and have high processing throughput. Okay, so as you see here, in this example where you have one instance, a node group is a set of one or more database partitions. When you create tables for the database, you first create the node group where the table space will be stored. Then you create the table space where the tables will be stored. And of course, each database, a typical database, has a set of transaction logs. So in this case, you have an instance, and let us say we have a database. Give it a name like sample or a shopping database or whatever. You have a database, and then for each database, you have a set of transaction logs. And these transaction logs are basically divided are three kinds in this case. We have an active log, an online log, and an offline log. Now, what's an active log? An active log is nothing but the log file that is currently being written to. So whenever on a normal database or in the typical database, all the transactions that are being done on the database first are protocols in a log file called active log. So in this active log file, the database is currently running. So whatever the transactions the users are doing are being written in this file. Now, once this file hits a certain threshold, which could be set in the database parameters, it switches. That means a log switches and it opens another file, another new file. So once that happens, you basically create the so-called online log file. Now, the active log continues to write and it continues to protocol what's happening on the database, and then you generate online log file. So your online log file are the log files which are required for the normal working of the database. That means the transactions inside an online log file may not be committed to the database, so they are very important. So until and unless all the transactions inside the online log file are committed to the database, They are very critical for the restore or recovery of the database. Now, once the transactions inside the online log file are committed to the database, they are archived, or rather stored off in another location, and they become the so-called offline log files. So now let's go to the second slide, which is the parallel database system. As I've already mentioned, DB2 allows partition of one database over several systems. So this is called the multi-node environment. And a database partition is a part of the database that consists its own data, indexes, and configuration files and transaction log files. Therefore, a database partition is sometimes called a node or a database node. As I already mentioned, we could have a single partition database or a multiple partition database. In a single partition database, you only have a database which has one partition. All the data in the database is stored in that partition. In a partition database, it has two or more database partitions, and tables could be located in one or more database partitions. When a table is inside a notebook consisting of such multiple partitions, some of its rows are stored in one partition and the other rows are stored in other partitions. And as I mentioned, why would you want to have such a setup? Because in that case, in case you're using a multiple partition database, you could use the power of multiple processors on multiple physical nodes to satisfy requests for information. The data retrieval and update requests are decomposed automatically into sub-requests and executed in parallel among the applicable database partitions. The fact that these databases are split across database partitions is transparent to users issuing SQL statements. And there is a coordinator who coordinates all these actions. Now, when we come back to the data protected part, we also support backup of partition databases. So this was first introduced with Data Protector 5.5. And in that case, as I mentioned, we support both single partition database and multiple partition database. So single partition database is quite straightforward, where you have one database which has only one partition and all the data is stored there. In case of a partition database, the databases are spread over different database partitions, and usually each partition belongs to a different physical system. Now you might ask, oh, how does data protector integration work in case in case we're talking about a multiple partition database? As you might have guessed, in that case, you have to install DB2 integration module in all the participating DB2 partitions, and then you have to configure all the physical servers, and you also have to configure specific backup sessions for all the participating partitions of your database system, and start the backup specification on that system, on that partition which hosts the catalog, system catalog. So that is an important point. Also, the restore works, in which case you have to start the restore on that server which hosts the system catalog. So basically, it's the backup and restore must be started first on the partition which hosts the system catalog. There is also a white paper which describes that, and that white paper could be downloaded, and the address of which I'm going to send out in a document at the end of the session. So let's go to the next slide, which is transactional logging. So as every database, we have logging for DB2 database, and we have three kinds of logging. The first one is the circular logging, second one is the capture logging, and the third one is on the next slide, which is archive logging. So let's go back to the earlier slide and talk about the different kinds of logging. So to kick off, we have the circular logging, and as the name suggests, the logs are handled in a circular fashion. When you install a DB2 database, you get circular logging, which is the default. What it does is basically uses a ring of online logs. That means these particular transaction logs, if you see in the picture, there, let us say in this example, you have 4 log files, online log files that are active, and they are being continuously being filled up. And of course, one of them is the active log file. Now, if you start off the log sequence with 1, it should be 1, it should be 2, 3, and 4, and number 5. When the time comes to fill up log number 5, log file number 1, which is this one, would be overwritten. The next step, log file number 6, would have to be accommodated somewhere, in which case it would be this file, which was previously log file number 2, and so on and so on. In this case, as you see, there are a ring of log files that are constantly being reused. So that means you do not have a constant or a neat history of log files of your DB2 system. So that's what this point is. So transaction log files are overwritten, and this kind of logging mechanism only provides recovery from transaction failures and system crashes. You can only do full offline backups of the database. That means you cannot perform online backup. Why? The reason is, since you do not have a consistent and an unbroken chain of log files, you cannot perform a full online backup. So the only possibility to secure your DB2 database is to perform offline backups. So that means you just make sure that the system is shut down properly, the database is shut down properly, and you back up. So in case of circular logging, there was a parameter in DB2 which is called log retain, and this parameter is set to no. However, if you set this log retain parameter to capture, you will find yourself having a database operating under the capture logging mode. So what this logging mode does is basically nothing but it behaves exactly like circular logging, except the fact that the log files are deleted at a certain point. That means this kind of logging, the capture logging, is used for replication purposes. So if you would like to replicate your database, you briefly switch on to capture logging, and the database collects all the logs required, all the log files required, successfully completing the replication process. And once that is concluded, DB2 automatically issues a command which deletes the log file. So basically, you're going back to the circular logging mode. So the same limitations apply as circular logging mode. And as I told you, the log retain parameter is set to capture. So we go to the next slide, which is the transaction logging. And this time the flavor is archive logging. So this is, of course, the ideal way to secure a database, in which case you set the system or set the system's log retain parameter to recovery. Now what happens is, instead of recycling the logs, which was the case here, if you remember in the previous picture, instead of constantly recycling the online log file, what you do is, before you delete an online log file, you save that particular log file to another location, and that becomes your offline log file. So now you have an active log file into which users are basically writing the transactions into, and once this active log file is filled up, it creates the so-called online log files. And once the transactions inside the online log file have been successfully written to the database, they can be archived, and thus they become the so-called offline archive log file. Now, for this to be possible, you have to set the log retain parameter to recovery. Now, by doing so, you allow online backups. So that means you can take full online backups, which is not possible in the circular logging mode. And when changes in the active logs are no longer needed for normal processing, the log is closed and becomes an online log. This is what I already mentioned here. So, and the logs, the online log files retain in the database log path. However, the offline log files could reside in an alternate location, which is not the database log path. Now, every time an online log file is created, and there is a certain program called the user exit program, which is provided by DB2. And this program makes sure that this online log file is archived, or rather backed up, to a non-database log path, and thereby it becomes an offline log file. Backup is done by the user exit program, and for this to be possible, the user exit parameter in DB2 must be set to on. So if this is set to on, this user exit parameter, the action of the online log file becoming an offline log file is automatic. So you do not have to worry about that. The moment there is an online log file that DB2 sees, it immediately executes the user exit program, and it saves them or archives them, and the archived files are called the offline log files. How does the backup of these transaction log files take place? As I already mentioned, it takes place because a program called user exit. Now what happens is when you integrate DB2 with Data Protector, which we will see later on, we are still in the DB2 section only. When integrating DP with the Data Protector with DB2, a particular module, which is provided by DB2, is copied over and renamed into Data Protector's location. So the handling is different in Windows and Unix. In Windows, it is copied over. In Unix, a soft link is created from DB2 to Data Protector. So every time there's an online log file that is generated by DB2, Data Protector automatically starts a Data Protector session which backs up only the archive log file. So as you will see later on, in Data Protector DB2 integration, there is no way you could interactively start an archive log backup of a DB2 archive log file, because it is completely automatic. You will even see an error message if you try to start an archive log backup in DB2 saying that, oh, this cannot be done interactively, it is completely automatic. I will show you that error message as well. So user exit basically is responsible for two things: the backing up of archive log files, and at the time of restore, it also retrieves the offline log file. This program, user exit, is called every time a new archive log appears. And this program is not called in parallel, it's sequential. Once a successful backup of the archive log is done, the archive logs are successfully deleted by DB2. Remember, Data Protector does not delete. This action is exclusive to DB2 only. And the backup of the active log is possible. It is called on-demand log archive inside DB2. So what are the different kinds of backups that are possible with Data Protector DB2? You have the full, incremental, and delta. So in case of a full backup, all the table spaces of the database are backed up. In case of incremental, it backs up all the changes since the most recent successful full backup. Remember, it's a successful and full backup. So basically, if you perform the full backup on Monday, on Wednesday, if you start an incremental backup, it's going to back up the changes from Monday to now. In case of a delta backup, it contains all the changes since the last successful backup and now. So the difference between incremental and delta lies in the fact that The delta backup covers the differences between the last successful backup, which could be anything, which could be a full or an incremental, and now. Whereas an incremental backup always covers the difference between the last successful full backup and the time whenever you're starting the incremental backup. What can you back up? What is the granularity of backing up in case of DB2? You can specify database or individual table spaces. So there is no hard and fast rule that you have to back up the entire database. You could simply specify which table spaces you want to back up. For example, there is a particular table space which is called sales.dbf, and if a certain company is doing extremely well, this table space will automatically be growing at a much rapid pace than the others. So you would want to secure your database. So you would rather do more frequent backups of this particular table space as opposed to backing up the entire database, which contains multiple table spaces. So that is possible in DB2 integration. So what are the types of backup that are possible? You could do an offline backup as well as an online backup. In an offline backup, the database or table spaces will be exclusively used by the backup process. That means no other user will be able to connect to the database to do any productive work. In case of an online backup, the database or the table space is accessible to users. And one important thing is always when you back up a database in online fashion, you must, at the time of restore, after you restore, you must follow up the restore action by another action, which is the recovery. So a recovery action always follows a restore in case you're restoring an online backup. Of course, for an online backup, you need to back up the archive log file. So for that, to facilitate this, you have to operate your database in the archive log mode, whereby you're generating the archive log files. So to facilitate that, the log return parameter must be set to recovery, and the user exit parameter must be set to on. So we'll go to the next slide. Let's talk about restore and recovery. In restore recovery, it requires exclusive access to the database. That means the restore of the table space can be performed while the rest of the database is online. This is a very nice feature. Imagine you have a production database which has a bunch of table spaces. Now, one of the table spaces is screwed up, so you wouldn't want to sacrifice the production of the rest of the table spaces, which are healthy, just because one of the table spaces is screwed up. So the DB2 Data Protector integration allows you to single out the table space which is screwed up and offers you the ability to restore just that table space which is gone down. So you need to select that table space, put it offline, and then restore it and recover it. So of course, this requires exclusive action to the database. What you also have is so-called version recovery, which means, as the name suggests, it is called version. Your recovery, you are recovering a particular version. This means all the changes since the last backup are lost. This is equivalent to roll forward recovery with the option without roll forward. What exactly is roll forward? In roll forward action, basically roll forward recovery, once you have restored a full backup and the corresponding incremental backups, you have to apply the transaction log file. And this process actually constitutes the recovery process. Now, this completes the recovery of the database, and you can reach a particular point in time or to its state immediately before the failure. So when you do a recovery, you can reach a particular point of time which interests you. For example, now it is 6 p.m. in the evening. You know you have done a major mistake at 5:10 p.m. So you would like to restore your system to, let us say, 5:09 p.m. And this is possible if you have a valid full backup which was taken before 5:09 p.m. and the corresponding incremental backup, and then all the log files that correspond to the time until 5:09 p.m. So you restore the full backup and then the incremental backups and the transaction log backups, which constitute the restore process, and then you start the recovery whereby you apply all the log files and reach 5:09 p.m. And then effectively what you have done is you reached a time in the past of your database at which time the mistake was not committed. So that's the sense of this action. Okay, now let's talk about the integration steps. Now, till now we have talked about the different features of DB2 and the different kinds of backups and online backups, offline backups, which parts of the database you can back up, whether you could back up the entire database or parts of the database which only interest you, and so on and so on. Now we talk about the marriage between DB2 and Data Protector. Now, to integrate DB2 with Data Protector, you have to install and distribute the so-called DB2 integration package. Now, how do you do this? So if you go to Data Protector, now if you could see or watch your demonstration window, if this is my cell, I have a cell which is called HPU 025. HPU 025, this is my cell manager, and on this cell manager I have everything. That is my DB2 server, that's the client, and that's the cell manager. If I go to client and I select the client, which is HPU 025, I see that I have installed DB2 integration module. So let me just install it again. I click on my client, right click and say add components. I select my server on which I want to install the module, then next, and I go select DB2 integration and say finish. This is going to take a couple of minutes, and what it is doing is it is installing the DB2 component. Okay. So while it does, and I'm going to go ahead with the slides. Okay, now then once you have installed the integration, you need to configure the integration. So what exactly does it mean by configuring the integration? You have to provide the information needed for the configuration, like which database instance you want to configure, the DB2 database user and password, and this configuration can be done either through the GUI or the command line. Once you have successfully configured the integration, you can generate a backup specification for the database and also for the archive log. And once you have generated the backup specification, you can run a preview just to check whether everything works perfectly fine. So this is basically a special DB2 function for SQL UB parameter check only. What this does is it does everything except the backup, pre-walk, etc., etc. Now, as you see here in your demonstration window, it is installing the DB2 integration. It's 82% over. I'm just going to do install the integration. Now, once you're done with the integration, you have to configure the integration. So how do you configure the integration? We have two flavors, that is in Unix and the configuration in Windows. Now let us see how it works in case it is Unix. Now I'm going to directly take you to the do a demo and see how the configuration works. Now we are in the process of installing the DB2 module. As you see, it's just finished 100%, and now we will go ahead and do configuration of the. Please everybody look at your demonstration window. I hope you have set it up. And let me go to the backup window, okay, context, expand the backup specification, and expand my DB2 server. So in this case, I already have some backup specifications. So let us configure the integration. You right click and say add backup. It shows you two templates. The first template is to back up the database, and the second template is to back up the archive log file. So since I'm going to configure this for the very first time, I select the DB2 database backup and say OK. And it the wizard takes me to the next window, and whereby I select the server, which is HPU 025, and the name of my instance. The name of the instance is the DB2 instance name. So because this is Unix, I also have to provide the user and group. And remember, this user with the group name is the owner of the backup specification. Now let me give him the values, which is DB2 inst1 and DB2. Let me check if they're correct. Say next. Oh, okay. It's configured. Now, what do I see here? This is my instance. So when I expand that, does anybody have a question?
No.
Okay, I'm going to continue. So you see here, for my instance, there is one database, and this database is called sample. So I could select the entire database here and say next. Select a particular drive. Next. I'm just going to take all the defaults and say next. 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 Save it. Say OK. And there I have, I saved it under test. So you could see we have a database that has been configured successfully. Now, if I want to check whether the configuration has been successfully performed or not, I can right-click and say, right-click my instance here and say check configuration. Say that again, please. Here it shows the integration is properly configured. So let's go back to the slide set and continue with the slide. Now what is important is that in case of Unix, it could be configured via the CLI or the GUI of the CLI. I have done it with this GUI. You could perform the checks or configure it in your lab exercise with the CLI. Now what is important is when you are configuring, you have to check some values. So this window pops up if you are looking at your demonstration window. It shows you the DB2 configuration dialog, which is the client and the instance name. Now there is a connection window here which shows you that you have to fill into a login and a password. Now what this actually means is this is a DB2 user which must be registered in the operating system. And this user must have specific permissions. And this user must have the sysadmin, syscontrol, and sysmaintenance authorities. And this user must also be in Data Protector's admin group. And this is the user who actually performs the backup. Okay? Now, once you fill up these values, okay, okay, it's successfully configured. Now, if you look at your slides, it says this action also creates a soft link for the user exit. Now, remember what the user exit function was? This function enables the database to request a backup application to which it has been configured to immediately back up the offline log file the moment it is generated. So now let us see how this soft link is done. Now, please look at your demonstration windows again. I will go to my server, Unix server, which is this one. I hope you could all see this. My host name is HP025. Now, let us check where this user exit functionality is located. Now, if I go to, first of all, I have to set the environment. Now, as you see here, as a result of the integration, the database DB2 user exit functionality has been soft linked to opt omni lbin DB2 arc. Now, DB2 arc, this is the functionality, this Data Protector's functionality to back up the archive log files. It says DB2 archive. So what happens is every time there's an offline log file that has been generated by DB2, it executes DB2 user exit functionality, which in turn executes DB2 arc binary from Data Protector, and this starts a Data Protector session to back up the archive log file. Now, I'm going to demonstrate that functionality here. As I already mentioned, please keep looking at your demonstration window. Now, I also created an archive log backup specification, which is basically backing up my database's samples archive log files, as you see here. Now, if I try to start my database archive log backup specification, remember I told you this is not possible. What does Data Protector say? It says, oh, you cannot proceed. DB2 archive log backups cannot be started manually. Now, how could I possibly live with that? It's good news because the Data Protector, there is no need to start the archive log backups manually. It happens automatically. Now let us see how this works. Now I'll keep on looking at your Data Protector monitor window. I will go to the monitor section, this open, and generate some archive log files. Now let's see what happens when I generate an archive log file. Now I have created an offline log file by issuing this command DB2 archive log for DB sample, and you see, whoop, in the data protector monitor window, it automatically started a data protector session which is backing up the archive log file. So if I go and click on that, you will see it is backing up that particular archive log file. Now, where are the archive log files? As you see in the demonstration window, the message is the archive log completed successfully. And where is the archive log file? It is in this location, as you see here. SQL001, SQL log directory, and it's log file number 3. And data protector says log file number 3 has been successfully backed up. Let us go. Check where is it. Here, right now we have log file 3, 4, and 5, and this session backed up log file number 3. Now I'm going to repeat the same action again, whereby I am going to another log file, which in this case would be number 6, and let us see what happens. Again, data protector should start. Oh yeah, it started another backup called DB2 archive log files. And now while this continues, now we could also check the location of this directory. You see, log file number 6 has been created and log file number 3 was deleted. Now if you go back to the session, active session, it says log file number 4 has been successfully backed up. So the next time you generate a log file number 7, log file number 5 would be backed up, log file number 4 would be deleted. So that's how things work. Now let's go back to the slide. And in case of Windows, it's pretty much the same, except the fact that the user and group functionality you do not have to do it because it works through the inet functionality. However, the user who is actually responsible for doing the backups must be given in this DB2 configuration dialog. And the only difference between Windows and Unix is this one. In this case, in case of Windows, DB2 arc, the binary from data protector, is automatically copied and renamed as DB2 user exit. So there is no soft linking, it is automatically copied and renamed. Now, I would like to briefly tell you that you are going to do the labs on Unix. Okay, now DB2 configuration, here the CLI. In this case, you are going to use the command util_db2 with the option -config, the name of the instance, the username, the password, and this configures the integration. This is nothing more, this is exactly the same information that we provided during the configuration of our data. And you could also check the configuration using the check on option. If you want to see what are the instances, names of your database, you can use -app. Or if you want to find out the names of the databases belonging to a specific instance, you would say util_db2 -objs0 and the name of the instance. If you would like to know the table spaces of that particular database, you would use so that what does the DB2 integration package consist of on HP Unix? It consists of the DB2 bar, which is actually responsible for starting the backup and restore of a database. It is started by the session manager. So you have the 32-bit flavor and the 64-bit flavor. And secondly, you have the shared library, which is called libob2db2. And this has a 32-bit and a 64-bit flavor. Now, this is responsible for the communication between Data Protector and DB2, which is actually like the shared library to use to transfer the data. It is called by DB2. Also, the famous DB2 ARC, which we have seen, this is responsible for to start the archive log backup of DB2 log files. It is automatically called, as I demonstrated it to you, by DB2. You also have util_db2, with which you use to configure or check the integration. On Windows, it's pretty much the same. You have the DB2 bar, but instead of using the shared library, you have a DLL, which is Windows specific, and this works exactly like the shared library in the last slide. It is used for communication between DB2 and Data Protector as the shared library, and it actually aids in the transfer of data between DB2 and Data Protector. It is of course called by DB2. You have the DB2 ARC, which is responsible for the starting and backing up of the DB2 log files, and util_db2, which is used to configure the integration. Okay, we have already seen this DB2 integration reconfiguration. What does this mean? Remember, if you please look into your demonstration windows. So this is my test backup. Now I have one database called sample that I have configured. Now imagine the usernames, the DB2 username and password have changed. Now you cannot continue backups using the old password. You have to reconfigure the integration. For that, you simply need to go to the GUI, or you could also do this in the CLI, by the way. You right-click on your instance and say configure. You can configure it again. In this case, you're going to give the, let us say DB2 inst1, the password has changed. You set the password again, and you go OK, and then it reconfigures the integration. Okay, that was successful. Now please look back at your slides. Now this is what we exactly did now. It could be done through the GUI or also through the CLI. Now, after successful configuration, there are some configuration data that are created by Data Protector and put on the cell manager. So these configuration files are two. One is an instance-specific configuration file, which is created per instance on a client, and one global configuration file. Now, for each DB2 server, there exist two different files, and both of them, as I already mentioned, are put on the cell manager. Now, in case of Unix, that are put under etc opt on the server, integ, config, and DB2. And in case of Windows, it's three program files on the back config server, integ, config, and DB2. It contains the username and password, which are encrypted, the OS version, the user exit bar list, and environment variables. Now, what is this user exit bar list? This is the bar list that is used to back up the archive log files. Now, for all the databases on your instance, it is good to have dedicated backup specifications for the archive logs. That means use a special drive to back up the archive log files, all the databases on your instance. That means keep it completely separated from backing up your regular backups. Now let us see how it works. If you please look into your demonstration windows, in my example, I have test, which backs up the sample database, and I have another backup specification called archive log files, which backs up the archive log files of my database called sample. Now, if you look at the destination, I have put it in such a way that my full backup runs on driver file, a driver number, drive number 1 or 0 in this case, and in the archive log files, the destination is another drive. So this is how you keep them separate. Now this is an important practice, and what happens is if you select the same drive, there's a deadlock situation and it takes time. That means you're running a normal backup of your database, and DB2 realizes that there's an archive log that has just been created. So it immediately pauses the backup, the regular backup, backs up the archive log file, and then starts the backup again. So this takes time. So to avoid this conflict, keep it completely clear, use two or separate drives for normal backups and the archive log files. Well, let's continue with the slides. Now that is what you see here. And there is also one global configuration file with the instance name. So now let's check these configuration files. Please look into your demonstration window. I want to take you to Intex, config, and DB2. So how many files do I have? I have two files. One is the instance specific file, which is to be this one because my instance name is DB2 inst1. And the other one is the global configuration file. So now let us check the contents of the instance specific file. As you can see here, it contains the username DB2inst1, the password which is encrypted, version is 64, and the user exit bar list is what? Archive log files. Now, do I really have this archive log files? Let me check it on my Data Protector GUI and see. Oh yeah, the name of the backup specification is archive_logs, and here you see archive_logs. Now, I could have multiple backup specifications that back up my archive log file. So in that case, what happens? In that case, the DB2 resolves this confusion by using only one backup specification inside the configuration file. And whichever backup specification is used here is inside this configuration file. Only that backup specification will be used for backing up the archive log files, even though there are multiple backup specifications to back up the archive log file. Now, what happens if you delete such a backup specification? If you delete, for example, this archive log backup specification, it does not automatically update this log file. So you have to make sure that you take care of that. Okay. So now let us go back to the slide. Next slide. Access to the configuration files. Now, since you generate an configuration files, you also have to take care of the configuration file. Now, how do you do that? You do that through what's called command line utility called util_cmd. Now, this command, util_cmd, is used to set or read parameters of the configuration files which are located on the cell manager. Remember, the configuration files are located on the cell manager, but with util_cmd, you can read and set the parameters of these configuration files which are remote on the cell manager. Now, when you want to set or read the parameters, the bar util is used to access, parse, read, and modify the configuration files. So, for example, you could set a particular option or read an option as to what kind of operating system is your DB2 server. And the important thing is these configuration files are ASCII files. So they could be simply opened in a text or a VI editor, and you can change a lot of stuff in that. But that presents a huge risk, which is why it is strictly forbidden to edit these files. It is possible, but it is not supported to edit these files directly. The corruption, the configuration might get corrupted, in which case the backups may not even work. So you should be extremely careful, and if you want to modify or read the configuration files, always use util_cmd. The different options are you can get to read what a specific parameter is, you can put or change the option, get it, or get the configuration option. Okay, now going to the next slide, which is backup specification to backup for database or table space. You could create it inside Data Protect's UI. As I mentioned, you could use the database backup template, and remember to select the right instance. The backup specification contains information of what you want to backup. You want to backup the database or individual table spaces. You also have the option of pre and post text scripts, media management options, the DB2 user and group name, and parallelism. And this parallelism parameter allows you to do the backup in multiple streams as opposed to one. So the number of data streams available per database could be increased by increasing the parallelism. Although databases are always backed up sequentially. Now, where do we find these options? So let us go and check out these options. Please look into your demonstration windows. And if I take my test backup specification, I can go to the Options tab, and there you see application-specific options. And I click on Advanced, and it shows me the pre-exit and post and parallelism. So right now, I could change it to a different number. So what I'll do is, first of all, I'll run a normal regular backup specification with parallelism 1. Let's see what happens. I ran the backup. Now let's go back to the monitor section and see what happens here. It has started a session. It is running the backup. Oh, suddenly you have another backup specification, session number 17. What could that be? Do you have any guesses for that? That is, I started DB2 test, which was backup of my database, and it automatically starts a backup of the archive log file. So every time, don't be surprised in DB2. It's nothing like you buy one, get one for free. It is indeed like that. You start the backup of your database, it automatically starts the backup of the archive log file. Now, let us see for the backup of the database, how many streams were used, how many objects were created. So I go to the internal database, go to sessions, and see, select my, oh, it created one object. Now, if I would like to create multiple objects, you can simply pump up the parallelism parameter, go to the Options tab, Advanced, apply, and start the backup again. See, there should be more than one data protector objects that gets created here. There you go. It completed the database backup in 2 streams. So basically we have 2 data protector objects that were created. Okay, so let's go back to the slides. Now let us see how a backup specification actually looks like. This is how it actually looks like. You have a bar list with the name of the bar list. Bar list means backup and restore list, which is nothing but the name of the backup specification. You have the owner. This is the user and the group name, and this is the system name. So let us go to our system and see how our backup specification actually looks like. I can explain you better there. So please look at your demonstration windows. Let's go to the backup specification list. I am in bar list DB2 directory, and I say I have 2 bar lists, archive logs and test, which is what you know. Now let us check out the contents of test backup specification. And when I do that, you see, it tells me the bar list name is test, the owner is DB2 Inst1, group is DB2 Group 1, the name of the DB2 server is HPU025, I'm using writer number 0, my client is HPU025, the name of my instance is DB2 Inst1, and it's executing DB2 bar, and it says backup with a concurrency of 2, which is the parallelism, and the database name is sample. So this is how the backup specification looks like. So let's go back to our slides. Let's see and check out how the backup specification to backup archive logs look like. Remember, we created the backup specification to backup the archive logs using the data protectors template archive logs backup. We also saw how it could not be executed or scheduled, and we also saw the error message. And this backup specification contains for which databases the archive log should be backed up. That means you can, in one archive log backup specification, specify a bunch of databases whose archive logs should be backed up by this archive log backup specification. Of course, you give some media management options like the data protection, catalog protection, log level, etc., etc. It is highly recommended to have different backup devices for archive logs and the database. And we will also see in the next slide, it is highly recommended to have only one backup specification to back up the archive log file. So in case you have several backup specifications that are backing up the archive logs for one database, how would Data Protector know which backup specification to take? Now, only that backup specification which is defined in the configuration file will be taken, which I showed you. For each database, at least one archive backup specification must exist. Otherwise, the log backups are not, archive logs are not backed up. Now, if you look at our demonstration window, in my example, I have test which is backing up my sample database. Now, as you saw, every time I was starting this backup, it not only backed up my database, it automatically starts archive log backups. Now, if I did not have this archive log backups, let us say I'm going to delete this backup. Okay? Now, what do I have? I only have a backup specification that simply backs up the database contents and not the archive log files. Now, that is not a good idea. Now, if I start this backup, you will see in the monitor context. Backs up. It is backing up just the database, but there is nothing to back up the. Let me reconnect. It is backing up the database, but it will not be able to back up the archive log files because there's no archive log backup specification, not even one. Let me go back and recreate one backup specification. It's going to back up the archive log file. Now, how to do that? I go to DB2 and say add backup, check the archive log backup specification template, automatically selects everything for me. I'm going to select a different drive. Next. Now, can I start it? Oh, no, can't do that. But if I start my test, it's going to start. Both of them. Let us see. This is my DB2 test. If I wait a couple of minutes, it's going to show up another backup session which is backing up the archive log. Let us see what happens. There you go. It is backing up the archive log files using the new archive log backup specification, DB2 archive. Now let us go back and check in the configuration file whether this was updated or not. We are in WD. I'm in the directory, configuration directory. I have two files. I'm going to check the instance specific file, and it sees it automatically updated the user exit bar list, which is archive. Remember, in the backup specification I deleted was called archive_logs. Now I deleted it and I created a new one, and the data protector automatically updated it. Okay, now if you see this one, it is backing up the archive log file. So there you go. Now please look at your slides again. Removing a backup specification doesn't update the configuration file. Even though another archive backup specification exists, the archive log backup will fail. So the recommendation is to have only one archive backup specification for all the databases on an instance. Now, how is the backup started? When the backup is started, you can select either full, incremental, or delta. If you quickly look at your demonstration window, you could see that I'm going to the backup and I say test, start, and you can see the three different full, incremental, and delta. Going back to the slides, A backup session can create data protector objects with the following naming convention. You have a host name, the instance name, the database alias, the timestamp, a backup type, and a sequence. So this is pretty much same for the database as the archive log file. Now let us see how it looks like. If you go back to the demonstration window, let me go back to one of the backup specifications, the backup sessions that just ran. As you see here, this is the name of my data protector object, DB2 Inst1. The name of the database followed by this notation. 2008, 11 is November, 19th is the date, 1830 is the time, and a backup type is 0, which is a full backup, and the sequence number, which is 1 or 2. So this is the notation of the data protector object. So let's go back to the slides. And say data protector also stores some metadata needed for a disaster recovery. So this is required when performing an online backup automatically and switches the active log. There is also the recovery history file, which is included in the DB2 backup image, and therefore it is part of the backup. Okay, now finally we come to restore. Now in the restore section, Data Protector GUI offers a restore of what? Databases and tablespace. So you could either choose to restore the entire database or parts of the database, in which case you could restore the table spaces. Also, you could restore archive log. So you could do these three things. Now what else can you do? You can do a point-in-time recovery. That means you can select a point in time and say, okay, I would like to have my database rewound to that point in time. And there are also two kinds of restore options, valid for all the objects or valid for a specific object. Now let us check out how this actually looks like in the GUI. So please look at your demonstration window. I'm going to go to the restore context, like my DB2 integration, my server, data protector object, and it says, okay. First of all, by clicking on this tab, allows me to select what I want to restore. So as you can see, I have database or table spaces that I can restore using this drop-down menu, or also the archive log file. Now if I select database and table space, I click on my sample database, and you see the different table spaces that I can select for restore. I could deselect some of them or say, okay, no, I would like to restore my entire database. So that's the difference in this one. However, if I select the archive log files, it says, okay, I could restore archive log file number 1, 2, 3, 4, 5, 6, and 7. Or I could say restore everything. I have to select each one independently. Yeah. So that's how we do it. Okay, now let's go back to the slide. Database specific restore options. You can right-click the mouse on a dedicated object and select a specific object and its version. Example. Now, how do we do that? Let's check out in the demonstration window. So if I want to select my database, I can select, right-click on it and say Properties, and select a particular version of my database for restore. So as you can see here, you have different options, different versions of the database that have been backed up in the past, and you can select particular versions of the database that you would like to restore. And I could select one of them, and I also go to options, and I say I could restore it. By default, it is restores into the same database, or I could say, hey, restore my database sample into another database called sample1. So I give my name here, sample. So, 1. is also possible. But there are other additional steps that you need to do. But I would like to first show what are the different options that you could do here. Okay, now also you have under options here different options that you can do. First of all, to be able to do the restore, you have to input the values like DB2 inst 1, DB2 1, sorry. Password is that, and restore to the same instance. Yeah, I have only one instance. And here I could say roll forward, and it says I can select a particular date, which is today's date, and I can select a particular time. You can say 9:39 p.m., etc., even down to the second. So even that is possible. Now this comes under roll forward. So you could choose not to have the roll forward at all, or if you choose to have it roll forward, you can go until the end of the logs or to a particular date. So let's go back to the slides. Then restore into a database. It is possible only if the whole database is selected for backup, and some manual steps are necessary for the restore can be performed. For doing an online restore, it is only possible if a dedicated table space was selected, and during the restore, the database is online and the table space is inaccessible. The global restore options are valid for all objects. It is accessible via the options button, which I showed you. There you give the username, user group, and password, and to the client, whether you want to restore to the same client or to another data protector client within yourself, or whether you want to do the restore to the same instance or to another instance on the same server. Remember, some manual steps are necessary, which are documented in your lab exercise book. I also showed you the roll forward section, which can be performed, or you could also deselect it. If you select the roll forward, you can have the option of recovering until the end of all the logs or to a specified time. If you deselect it, it will not roll forward it. That means it will not perform a recovery after the restore. The database will not be available until you actually perform this roll forward. So if you do not select this option in the GUI, you could still do it from the DB2 command line as a separate action. As I also showed you, you can restore the archive logs by selecting this drop-down menu, selecting archive logs from this drop-down menu, and select the particular log file that you want to back. Actually, in other integrations of Data Protector, you never get to see this. This came through because of the customer escalation, and the customer really wanted to have the ability to restore archive log file. But the point is, Data Protector automatically determines which archive logs are necessary for a restore and recovery, and does it automatically for you. However, because it was the customer's desire to have this, we coded it. But technically, you do not need this. Everything is an automatic procedure. You only specify the goal in terms of the time you want to go back in, or to a specific log number, etc., etc. Now, how does this whole integration concept look like? And this is an important slide whereby you have the Data Protector Cell Manager here and the DB2 server on the left-hand side. Now, when you start the backup session on the Cell Manager, the bar list or the backup specification is spread on the Cell Manager, and the Session Manager is spread on the Cell Manager. The Session Manager has to contact the DB2 server. Now, how does this work? The Session Manager contacts the INET port 5555 on the DB2 server, which is the application host, and once it is contacted on the INET port, the application-specific interface, that is whether it is Windows or Unix, depending on the flavor, either the shared library or the dynamic link library is started. I mean, remember when we discussed earlier, these two guys, the DLL or the shared library, are the communication guys. They're responsible for communication between DB2 and Data Protector Cell Manager. Now this takes over the control and contacts back the Cell Manager on the port CRS, which is Cell Request Server. At this point, the Session Manager checks whether there are enough licenses to cover for the backup. That means the media agents. So if there are not enough licenses, the drive licenses and the online extension license, which is required for running this backup, this backup session aborts there with a message, of course. But however, if there are enough licenses, the Data Protector Cell Manager talks back to the application server and gives it the set of ports that it has to pump the data to the media agent. The media agents are ready in the meantime, and the DB2 server creates the different backup sets. That means the containers through which it is going to push down the data to the media agent. So as you see here, DB2 server directly pumps the data from the database DB2 server via backup sets to the media agent. In this case, the data flows directly from this DB2 server to the media agents and not via the Cell Manager. And once this backup finishes, the Session Manager updates the internal database of Data Protector with the session information, the session messages, the logging level, the data protection, and the catalog protection, etc. And then finally the session comes to an end. So this is how the entire integration looks like on one piece of paper. Talking about the limitations, the backup and restore using DB2 command line processor or DB2 control center is not supported. You have to use OmniB and OmniR to start the backup and restore via command line. Table and data file backup and restore is not supported. You can only backup table spaces but not tables. We're not supporting DB2 cluster either in MC Service Card or Windows cluster. Zero downtime backup and instant recovery is not supported either. There are some scripted solutions and it is possible. However, remember it is not supported. Among other limitations, restore to a new database is only supported for database level backups. You have to perform the redirect, and this is not possible due to DB2 limitations. And to solve this, these two variables, DB2 code page and DB2 country, have to be set. Data Protector requires that log retain and user exit are enabled to perform automatic backup restore from an incremental or delta backup. Fixpack 7 must be installed if you have DB2 installed on AIX 5.x systems. In troubleshooting, there are different nice interesting log files like the db2.log file, which is dedicated for DB2, debug log file, which is a very important log file on Data Protector side, which contains exceptional errors. So always keep an eye on this log. I mean, these are the two different flavors in Unix and Windows. If no valid user exit archive backup specification is specified inside the configuration file, the database backup will be successful, archive logs backups will not be backed up, and the db2.log contains an error message. That means after creating a new database, existing archive backup specification must be updated to include the database, the new database. Otherwise, the db2.log file will contain some error messages. After the deletion of a DB2 instance, when creating a new backup specification, DP still shows this instance which could be chosen for backup. So So basically, you just have to ignore it. Remove the instance from the configuration file manually. The user root must be a member of sysadmin group. Otherwise, DB2 structure cannot be browsed inside the DB GUI. Offline backups are not possible if users are still connected to the database. After configuring a database with user exit and log retain, online backup is not performed. How is it performed? At first, you have to complete an offline backup, which could be done from the DB2 command line utility. Delta and incremental backups require that a particular option is enabled, which is called the track mode, and increase size and number of buffers for performance tuning, or you have some additional parameters in data protectors that you can choose to do that. Okay, so that actually brings us to the end of the session.